Hello and welcome to another tutorial. So this time we are going to be taking a look at being able to run background tasks in the editor. So this is something where some nice support for being able to provide feedback in terms of progress to user was added quite a few Unity versions ago. So we're going to take a look at how we can actually work with that, a couple of the pitfalls, things we need to be aware of there, and a few solutions to work around those. So let's dive right on in. And so the first thing we're going to do is actually just create some simple little things that can run in the background. So what I'm going to do is just have a very basic demo script. That's something that I'll attach onto an object in the scene. And then I want to have some custom editor side scripts. So we're going to be setting this up so we'll have a mix of sort of editor and runtime code. So that's also, we'll be able to illustrate how we actually can blend those two together. So we'll set up a script here. So this is a demo script editor. All right, so demo script is going to go onto an object in the scene, and then we'll have our custom editor for that. Demo object. Let's link that up. So in terms of what the demo script does, it doesn't need to do too much. It's actually going to be pretty simple, the stuff that it will do. And the editor script, this is going to be a custom inspector. So we'll bring in using Unity editor, and this then needs to inherit from editor, and we set this up as a custom editor for our demo script. That means we get rid of these, but then what we have is we take a look at the functions we need to set up. If you ever forget what functions you need to set up, you can go and take a look at the definition for the script. That's an easy way of them being able to identify the particular functions, because that's going to show you all of the different functions that are there. So things like our draw default inspector, stuff like of that. Whereas in this case, what we're looking for, it's going to be our onInspector GUI. So that's something where we know that's what we're overriding. So public override void, and we'll be able to actually, our onInspector GUI will be there as an autocomplete option. So I'm going to let it draw the default inspector. So draw default inspector. And then I'm just going to draw a simple little button that can run a bunch of our editor specific code. So we'll have F GUI layout button, and we just need to provide, in this case, we'll provide the text label for it. So we'll just call this perform background task. And then that, so we can access our particular object, so in this case the demo script, and gotta say the autocomplete is quite impressive in this current version of Visual Studio. So then in our demo script, what I'm going to do is, this might be something that runs at runtime, but we need to have some custom editor stuff for it. So what we can do is an F Unity editor, and F. That allows us to selectively have some bits of logic there that are only going to be compiled within the editor, because what happens with these preprocessor directives is if they are present, then this code exists. If this preprocessor, if that Unity editor defined isn't set, it's as if this code isn't there. So it gives you a way of having, it's really quite efficient because it's solved at compile time. So really handy way of working with stuff like of this. It's how a lot of cross-platform stuff is often handled, because you can check, well, if I'm on this platform, run this code. If I'm on this platform, run this other code. And you just present the one interface to everything. So really handy approach there. So again, we'll check for Unity editor. And what we'll have is just a public void perform background task. So this is something where, okay, we've got this, we'll link up the button and run that. And this will just initially test to make sure this is working. Always good once we've done our initial setup, just to make sure we're pretty confident the things are connected, but we just want to double check. And then we'll start looking at the background task stuff that we can make use of. So with that, when we select our demo object, we've got perform background task. Okay, so we've set up our script, so we just need to make sure we've got the logs on, we run it, we get the message, cool. So let's take a look at the first part of stuff for the working with background tasks. So one of the big things if we've got background tasks running is you really want to be able to provide feedback to the user of what's happening. And so one of the things that exists in Unity is something called this progress API. So we can actually say, well, progress, and we can say start, and then we can give it a name. So for example, custom background task. There are also options that we can provide to this. So this allows us to indicate sort of the types of options that we've got there. So it can be really handy. There's some stuff there where you can have it sort of auto-managing. You also see you can have subtasks here, which can be really cool as well, because you could kick off a big option and then you have small subtasks under it, which could be really cool. So you could have like a parent background task for several different stages and then child ones under that, which is cool. Now, when we start one, this gives us back an ID. So progress ID, and we want to store this. This is really important to make sure we store that, because then what we can do is when we want to say that the thing is finished, then we can go, well, remove progress ID because we're finished. So we can also update the status. So we can do progress report, and we have a lot of options of what we can provide here. So we need to provide the progress ID, but we also can provide a floating point number to indicate the progress. We can provide that plus some text description. We can indicate a number of steps. So what step we're on out of how many steps, and again, text as well. So it gives us a lot of good options in terms of providing feedback. So again, with that idea of having parent and child tasks, you could have a parent task that is 5 steps. So you're indicating the step stage with it, and then the child tasks might use that percentage-based one. So it gives us a good level of flexibility there with this. So say I kicked off something where, let's say we use the step-based one. So again, progress ID, I have to provide that. And we might be at step 3 of 10. And that could be, currently performing step 3 of 10, just as an arbitrary message. Now this, because we're just immediately running it, completing it, that's going to just complete like that. It's going to be very, very rapid. But if we run this, then it will have actually added to the background tasks, which you can access stuff like the background tasks down here, but inactive ones will already have been cleared. So if I don't clear it, so if I don't remove it and then run this, then we should see an entry gets added, but then it doesn't actually disappear. So I run it, so it's going to sit there. It's going to, can say that's the text message we put there, but this is an important thing. You see how quite rapidly it went to saying that it's not responding. So those progress options do feed into this. And Unity, if we're not regularly reporting, the status there, it will actually say that this task is not responding, which is great. That means that you've got a lot of ways of being able to know where the status of things are at and for signaling that status so the user knows what's happening, which is really cool. So that lets us see the status there. And after a timeout, that will actually go and be able to be cleared. It'll be considered to be inactive. So Unity will just treat it as then inactive and done, and then you can clear that actually out. And that happens after a set amount of time. I don't recall off the top of my head what that set amount of time is, but it's usually a few minutes from what I've found with testing. So, okay, that's cool, but that means we then need stuff running in the background, because say we had an operation here that was really, really slow, and we were just doing this, trying to do progress report on it. So say I had something like this. Actually, I'll use a for loop for this. For int sample equals 0, sample is less than 10, and then plus on that. And I could bring this up. The progress I could feed through sample plus 1, update the message here to processing sample, and then just output that. So I could do that, but what will happen, even if I put in like a delay, so I could put in some operation here that causes a delay, and that what will happen is the progress won't actually update until it reaches the end. The reason being is that if we are running something, in this case, in the main thread and consuming all of that main thread, the UI never gets a chance to update because we're essentially consuming all of the available time there. So if we want to have stuff run in the background, it needs to actually be in the background. That means we need to have some mechanism where either it's running in chunks and getting resumed automatically in the background, or where it's actually running in a separate thread. So that's something that's really important there, that we need to be able to do that. Because if I put in stuff for this to actually sleep for a time, and if I make it for even a reasonable chunk of time, we will notice that the progress stuff never actually updates. So if I chuck in a little bit of a sleep, so if I do system, threading, thread, sleep. Now this is a number of milliseconds. So say I make it sleep for 2000 milliseconds or 2 seconds, then go and run this. And we can see it's timed out. So that's good. So, okay, we're going to tell it to perform the background task. So it runs, but as I said, it's in the main thread, so we get this happening, where Unity is going to sit there because it can't do anything else, because we've essentially done a blocking call. So we have to run stuff in the background. So we've got a couple of ways for running stuff in the background. And we can see nothing ends up appearing in the background tasks, because from Unity's point of view, this has run, and then effectively immediately after, this has run, which is not ideal. So for running things in the background, we have a couple of different ways that we can go about this. So one option that is built into current versions of C# is using something called tasks. So I'll show you how that looks. Now, tasks have a couple of really important things that we need to know about with them. The biggest thing that impacts for running stuff in the background in the editor is when you kick off a task, it is running in a separate thread to the editor. It's not running in the main thread. What that means is we are restricted in what stuff we can safely do. Not everything is thread safe, and in particular there's many things that are not thread safe. So for example, say you were doing procgen terrain. You couldn't do that in a task because that task doesn't run in the main thread. So you can't directly access with the Unity terrain objects. What you would have to do is keep everything yourself in memory, do everything in the thread, and then once that's all done, apply that back. And when I say do everything, in the thread, that means beforehand you would need to cache anything that you're trying to read from the terrain. So it's not just in terms of being able to make changes that we're blocked from being able to do. We will also be blocked from being able to read many things when we are running something that's in a separate thread. So we're going to take a look at how we set this up, but that's an important thing. Tasks are okay if you make sure you structure things so that any of the operations that are working with non-thread safe sections happen in the main thread. That can mean a fair bit of rework potentially for the structure of things, but is something to make sure you keep in mind. So, okay, I'm going to bring in using system threading tasks, and we'll set up a function here that is going to be the task-based version of this, which is pretty straightforward for setting up the task-based version of this. So what we can do, the way we actually create tasks is reasonably straightforward. It's a pretty clean, simple process. So to do this using a task, and this is using the async setup in C#. So what I'm going to do is we'll put this in a separate function. So public void, call this C# async and task. And then what this is going to do is we can go, and this will actually, rather than just being this, we'll say that it is an async task. And then we can go and say, okay, well, await task run. And then we can just give it our logic, which we'll just do that. Then in terms of what it does, so, okay, we will bring over these bits of logic here. So C# async task. We'll again have the progress ID here. So we don't necessarily need to remove it, but that's something that we can do. What we would then be doing is bringing this over like that. Now tasks, we can actually do a task delay. Again, it's an amount of time in milliseconds, and we'll say that we want to wait for that to complete. So, okay, that will work, and then we can actually just directly invoke this function. So what I would do, and I might set this up as another button, so perform C# async task, and we will rename that. Bring this over. So this allows us to easily just compare how the different things behave. Now it will give us this warning because we're not telling it that we're wanting to wait for the result. And it specifically is telling us, it's not going to be awaited. The current method continues before it's completed, which is what we intend. We don't actually want to wait for it to finish. We want to kick it off, let it run in the background, and done. So, okay, let's run our C# async task. So that's running. We can see progress is updated again. Editor, everything is still functional. So everything is still updating. Our progress updates here. We can see the status of everything. Now, as I said, the catch is there's a lot of things that we're not able to access because this is, so thread safety matters. And then when it's done, disappears, which is great. So C# async tasks, that is a really great way for running stuff in the background. Just need to be careful of how we structure it. If you had something where it's like a background program that's running, so a good example there might be, if it was processing a lot of external data and then at the end of it imports it, that processing of the external data, that could be something that is running in tasks there. So they're a really good option, really straightforward to set up as we saw. The key is we just need to be mindful of the fact that they can't access a bunch of things in the editor because a lot of things are not necessarily thread safe. But we have an option. So one of the things that is now available and has been for a little bit in Unity as an experimental thing, but is now fully available, is something called editor coroutines. So coroutines run in the main thread. They're not running in a separate thread, which means we can do stuff in a coroutine that we can't do in a task. Now, normal coroutines won't work in an editor in terms of they don't actually work. But Unity's editor coroutines, which is now available, so we can unlock that to make sure that we've got access to it. So it's a really valuable thing for us to be using. So we can now use these editor coroutines. Because editor coroutines, so normal coroutines relied on a game object being ticked for updating, and they had to have a game object. Editor coroutines can actually work without a game object, and as the name suggests, can work in the editor. And the way we work with them is not very different. So for accessing the editor coroutines, there is a separate using we need to bring in. So we need to bring in, and this is a little bit of a differently named one to what you might be used to. So editor coroutines, editor. And then the way we set this up is actually exactly the same way that we would normally set up a coroutine. So we're going to have a enumerator perform editor coroutine task, and I will do a little bit of a wrapper around this to make it so that there's a function that the setup can actually run. So this, I will create a public void and might actually call this internal just to make it clearly named. So again, can do the same logic that we had up here. So in each of the cases, our logic doesn't end up needing to change much, which is really nice about how all of these are actually set up. So again, we set this up. So editor coroutine. And then rather than using task delay, we would do a return yield, return new, wait 4 seconds, waiting for, same as we're doing with the others, waiting for 2 seconds. And then for starting the coroutine, we use editor coroutine utility dot start coroutine. And this is where we can provide it an owning object, or we can have it run ownerless. So it doesn't actually have something that is the owner of it. So in this case, I'm going to use the ownerless one, and we give it our particular task. So we need to change that to that. So that's good. Now we can just run this from here. So we'll set up another one that is our editor coroutine one. And again, we just modify this to form editor coroutine task. So, okay, we've set up our version here. Looks straightforward. We've written it like we'd normally write a coroutine, essentially. So let's go and run this. And we run it, and it completes immediately. And that is because there is, apart from how we start the coroutines being a little bit different when it's an editor coroutine, if you're needing to wait for seconds in an editor coroutine, you can't actually use the normal wait for seconds. So when we're working in the editor, we can't actually use wait for seconds. We actually have to use, there is a special editor wait for seconds. The regular wait for seconds, if you use it, completes like that. So we use an editor wait for seconds. Then we go and run this, and we'll kick this off, and we'll see. Runs in the background, every 2 seconds is updating. So we do write the coroutines almost identical to how we otherwise would. The key thing is we just need to be aware that when we're doing this, they have to actually have little changes there, like the editor wait for seconds, rather than a wait for seconds. But it runs, completes. So we've got our background task version that is not background task, and we will actually rename that. More accurate naming for it. We've seen our coroutine version, we've seen our task version. The final thing I want to take a look at is, because we did say that, we've got this idea of parent-child tasks in terms of in that progress dialog. So let's take a look at how that would actually look. So I'm going to set this up as a coroutine based one. So what I will have is public void perform compound task. So what it's going to do is we'll have a parent coroutine. So an IEnumerator perform compound task internal. So similar to the other ones, we will do a progress ID. It's equal to progress start, and we'll have compound task. We'll also then remove it at the end. So remove our progress one. And you can see there's actually, if we go and take a look at this, there are quite a few things in the progress API. We've got starting, we can indicate stuff's finished as well. So that's something where for this one, I might actually go for saying that it has finished. And you can indicate the result of that finishing. So whether it succeeded, things like that. So I'm going to say that it succeeded. So that's good. But we want to have our child tasks. So what I'm going to do is set up another IEnumerator. So perform compound task child. I'm going to pass through the parent ID, so parent ID, because that will allow me to say, okay, well, progress ID, so progress.start, and we can see the different versions that we've got here. So we're going to just have the description. The name is child task. Now this is something where then we need to potentially provide through other ones here. I'm going to just make it that the description is still null. The options we'll keep as none, but we will pass through the parent ID. And then when we're done, we will do a progress finish progress ID. So not the parent ID, but just for this child task. And we'll just have a for int index, and we'll just go from 0 up to 100. And then our progress, we will be able to do a progress report. Will indicate that it's for progress ID, and the progress, we will provide that through as a floating point number. So we'll say a float of index plus 1 divided by 100, and we'll just do a yield return new, wait for seconds, and we don't want it to be waiting for too much because we're going up to 100, so we're going to make this, if we make it something like 0.1, I might actually make it 0.05, so it counts up pretty quickly. So that's good. Then what we would do in here is we'd have an editor coroutine utility, start coroutine. Actually, we don't need to do that. We can just do a yield and a return perform compound task child, and we pass through the parent ID. So we'll just wait for that. Then we're going to have a couple of these, because let's have a few different ones, because then we can update our general progress here, where we would say, well, progress report for this one, and we'll say we're at step 0 of 3. When we get to this point, well, actually, we'd say what stage we're running. So that's 1. This one we're running stage 3 of 3. So that looks good. We can start coroutine ownerless, run that task, and we'll then set up our logic here just to have that compound task. So this just gives you a bit of a structure of how we could organize something like of this. So a compound task, I'm going to say perform compound task. So it's going to run. It's going to set up with the progress system for the compound task. It's going to then indicate which stage we're running on, 1, 2, or 3. And then it's going to, with each one of those, run these child tasks, and then at the end, say that it's finished. So let's test this out. Got our different options here. We're going to kick this off. So you can see, it runs pretty quickly because we had it ticking quite a rapid rate. So we'll actually slow that down quite a bit, just so we have a bit more of a chance to actually see what's happening there with it. So we'll run it. I'm going to slow it down even more, actually. It's just 1 second. Oh, that's because I'm using the wrong wait for seconds. It's force of habit. It's really easy to forget, and you end up using the wrong wait for seconds. So we'll return it back to what I originally had. So yeah, really important thing to watch, because especially it's so easy to actually have the wrong one there. So now we run it, and that looks better. So we can see the progress, compound task, and you can see it's nicely nesting the things under it. It's going, and those tasks, because we're doing remove, they disappear, but we could also, and we'll do this once this is finished, we could then be saying, rather than that, for each one of these, we do a finish, and we'll provide the particular status. So we can say succeeded. And you can actually, with the progress thing, the options here, if we take a look at these, we can do things where, and if we expand these, we see the descriptions. So if it's sticky, then it's going to remain even after it's completed. You can have ones where it doesn't show the length of time. So there's a lot of really cool things that we can be doing there with sort of the options, and see stuff like there where it cancels things supporting it, etc. So this is something where if I changed the options there to sticky, then that's going to have it persist. We could then do the same thing for the parent one, and provide the options there in terms of that remaining. And what we will see is it will actually stay around after it's finished. So we'll perform that compound task. First one's going to run, and we'll see that finish. Now that's finished, and we can see which ones are actually done, and we get a nice indicator saying things are done or if they have failed, which is great. It gives us a way of running cool stuff in the background, providing feedback, and you can see it automatically collapses there. So, okay, we've got our key different ways of running things in the background in the editor and providing feedback to the user. We can use C# tasks if we have stuff that is only interacting with thread-safe things. So we need to keep in mind sections of Unity like terrain, stuff like that are not thread safe. So you cannot access those from within a task. And when we say access, that doesn't just mean writing, it also means reading operations are not safe. So for that, if we were wanting to, we'd have to structure things so it runs some stuff in a task after having grabbed all of the necessary information, and then it applies that data afterwards in the main thread. The other option we've got is editor coroutines, which those work really well. They work almost identical to how we normally set up coroutines. There is a package that we need to make sure is there, but the other thing that we need to watch for, and really easy to run into, is we don't use wait for seconds for an editor coroutine. We have to use editor wait for seconds. Otherwise, it's not going to actually wait for that length of time. It needs to actually be using that editor wait for seconds version. But this gives us stuff of how we can run things in the background and report status and have it that we're not blocking interactions there for the user, and more importantly, let the user know what's happening in the background and give them some sense of indication of the progress of where things are at, which is really great. That means that people can tell, is this actually making progress, or has it crashed or hung, or something's gone wrong with it there? So really important to make sure we're able to provide that information, that feedback to the user. Thanks folks, I hope you found the video helpful. If you're looking for the code for the project, I've put the link to that in the description below. You can freely use that code in any of your own projects, commercial, non-commercial. You can use it in any of those. And if you've got questions, chuck in a comment below, or if you want to submit a question for the next Q&A video, you'll find a link for that in the description as well. If you found the video helpful, please do chuck a like and subscribe in, it really does help out. And if you're looking for other ways to support the channel, then I do have a Patreon, and the link for that's in the description below as well. Until next time, bye.